All right, so we're going to talk now about a method for figuring out how many positive and negative roots there'll be, right? Descartes came up with this, and this was, what was that, like a couple hundred years ago, a few hundred years ago, 1600s? Rene Descartes, philosopher, responsible for a lot of different things, but he wasn't alone in all of that, but kind of. In conversation I've had with my colleagues, I guess this is what you do in the 1600s. Maybe you're just so bored, you got nothing to do. You can't like Snapchat or nothing, right? So you're just going to figure out how many positive and negative roots there are in a polynomial. And that's exactly what this rule does. Descartes' rule of signs, it's a method for figuring out the number of positive and negative roots there are, but it only works for polynomials with integer coefficients. Now, I'm going to show this in a way that I saw someone else explain. I myself watched a YouTube video and figured it out, and then I made it my own. This is all that you do. You look at f of x, right? You look at f of x, and we create a little table here. Positive, negative, and I'm going to include this for imaginary. So the whole idea here is this is a piece of a puzzle. If I'm looking at a polynomial and I want to find the roots, I'm going to use a couple different things. The first thing I'm going to use is I'm going to look at the degree of the polynomial. It's 5, right? So the biggest exponent here is 5. And so I know the degree is 5, so that means there must be 5 roots. Now, not all of them will necessarily be real roots, but there must be 5 roots, right? And that's going to help me. That's the first clue. The second clue I'm going to use is I'm going to use Descartes' rule of signs, and that's going to tell me how many positive roots there will be, how many negative roots there will be, how many imaginary roots there will be. All right? So this is what you do. It's the rule of signs. So we're talking about sign, like positive, negative. So you look at this, and you're going to count how many times the sign changes from positive to negative or negative to positive. So right here we're at positive. And then I'm going to do this because it switches to negative, right? Then it switches to positive, and it's positive, 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 positive. Then it switches to negative, and then lastly it switches back to positive, all right? So I like this little method. You draw a little line, draw a little bump there. 1, 2, 3, 4, 5. 1, 2, 3, 4. So it's possible that there is 4 positive roots, okay? Then we're going to jump right to the next thing. How do I figure out the negative roots? All you do is do f of negative x, all right? So f of negative x. The hint here is if you have an odd exponent, like 5 or 3 or 1, you are going to change the sign. I mean, that's the shortcut. Really what's happening is we're having negative x plugged in here. So negative x times negative x times negative x times negative x times negative x, that's going to be negative x to the 5th, all right? This is going to be an even number of times multiplying a negative x, so that's going to stay the same. X to the 4th power. Then this is an odd power that's going to change. Then this is even power that's going to stay the same. And then this is that one's going to change, right? So that's going to be plus x, and then plus 5 stays the same. All right? So now I do the same thing. I look at negative f of negative x. Here's all my new signs. Count how many times the sign changes. It's negative, it's negative, it's negative, it's negative. Oh, it switches to positive. Then it's positive, 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 positive. So it changed once. There we go. Now, the degree of the polynomial, it's 5. It's a 5th degree. So 4 here, 1 there. No imaginary roots. There's not going to be any imaginary roots. Okay? There's a little trick to this, though. This is possibility 1. Man, I'm straight up stealing this from someone else's YouTube video, but it doesn't really matter. As long as you see mine, you can go find someone else's. Okay, so there's another possibility. This is just one possibility. It turns out, if you go and you read in your book, Descartes' rule of signs, it turns out that it's kind of a wordy the way that it says it, but it says that there must be 4 positive roots of this polynomial, or less 2, or less an even integer, right? So what we do here is this is possibility 1. In possibility 2, I start with a positive. If I can subtract 2, then I do to get the other possibility. So I wouldn't say 3 here. I would go down by 2 each time. So 4 and it goes to 2, right? So there's another possibility where maybe there's only 2 positive roots. So there could be 4, it could be 2, and then I just do the same thing here. Could this come down by 2? So could I subtract 2 from 1? I could subtract 2 from 1, but then I would end up with negative 1 possible negative roots. That doesn't make any sense. So since I can't subtract that, just leave this as 1. All right, so if there's 2 positive roots in this possibility and 1 negative root, there's got to be 2 imaginary roots. Now, imaginary roots are always going to come either 0 or 2 or 4. They always come in conjugate pairs. There's always going to be a pair of these, or there's going to be 4, 4 or 6, something like that. Then I do the same thing. This is possibility 2. And then there is a possibility 3. The possibility 3 set, is reduced by 2 again. I could have no positive roots. I can reduce that by 2. All right, these are the different possibilities, but I can't reduce this one at all. So there's just one possibility, and then there's a remaining. Remember, the degree is 5, so I've got to have 5 roots. Here's one real root that's negative. The remaining must be imaginary. There could be 4, right? There's 2 different pairs here, 2 and 2, to make your conjugate pairs for the imaginary, the complex roots. All right. So there's my 3 possibilities: 4 positive, 1 negative, 2 positive, 1 negative, or no positive and 1 negative. Now, how is that helpful? Well, I'm going to make another video here in a second, and it's going to talk about the rational roots theorem. So you basically use a lot of different clues. Like I said, first you look at the degree, you can do the rule of signs, and this gives you this nice little list here. So if I were to be guessing what roots are part of this polynomial, what are the roots of this polynomial, I would want to guess a negative number. Why? Because in all 3 of these possibilities, there's a negative root. So I know there is a negative root in this polynomial. I don't know what it is. I know that there is going to be a negative one. It might not even be a rational number. I have no idea what the root is, right? It might be negative square root of 17. I have no idea. But if I am guessing, I'm going to choose a negative number if I have a list. And that's exactly what we're going to do next. Good luck.